Hello everyone, welcome you all in my YouTube channel Engineering Guru. Today in this video, I will cover one more important topic of construction and working of reciprocating pump. Let's see one by one. First, I will cover the component of reciprocating pump. Here, this is the schematic diagram of reciprocating pump. This is the piston, this is called cylinder, this is crank, and this is connecting rod. So I will cover in detail one by one. First, that is the piston and cylinder. So this is piston and this is cylinder. Piston reciprocate inside the cylinder. The reciprocating motion is obtained by means of connecting rod. The piston is connected to connecting rod by piston pin. So this is the piston rod, this is the piston, and this is the cylinder, and this is crank, and this is connected. So whenever this crank rotate here, that piston will move like this. So this motion is called reciprocating motion. Crank and connecting rod mechanism. Crank is mounted on the crankshaft, which is driven by prime mover. Crank is connecting rod to the piston by connecting rod, which convert rotary motion of the crank into reciprocating motion of the piston. So here this is the crank. So that crank connected with the prime mover. So whenever it start, the crank rotate in clockwise direction like this from 0 to 360. So whenever this crank rotate like from 90 to 180, the crank attach with the connecting rod by means of piston pin. So it will move like this, and this crank motion will be rotation. So that convert into this reciprocating motion. So that's why it is called reciprocating motion. Suction pipe, it connects the source of water and the cylinder. In this figure we can see that this is the suction pipe, so that connected with the source of water, or we can say sump, and the suction pipe one end connected with the sump and another with the cylinder. Then suction valve, it is a non-lethal valve which admit the water from suction pipe into the cylinder. In this image we can see that this is the suction valve. This is the one-way valve, means only water can enter this cylinder. So that's why it is called suction valve. So whenever pressure is decreased, this valve will close. So cylinder water will not enter the suction valve. Delivery pipe, water is discharged from cylinder at high pressure to require the height by means of delivery pipe. So here this is the delivery pipe. Delivery pipe, one end attached the outlet and another is attached with the cylinder. And final, it is delivery valve. It is the non-return valve which admit the water from cylinder to delivery pipe. So here this is the delivery valve, and it is also non-return valve, means one-way valve. So from the cylinder the water will pass like this from this delivery pipe, but the water cannot enter like this valve to cylinder. So that's why it is called one-way valve. Now, working of single acting reciprocating pump. So when the crank start rotate, the piston move forward and backward into close fitting cylinder. So in this image we can see that this is the crank, this is connecting rod, this is piston, and this is the cylinder. So whenever that crank rotates, the piston will move forward and backward. You can see this is the forward and backward motion. During the suction stroke, the piston move toward the right from IDC. IDC means inner dead center to outer dead center, that is ODC, that is from 0 to 180 degree in clockwise direction. Thus, the create the partially vacuum on the left side of the piston cylinder. Now understand how can it work. So this point is called point IDC. It is inner dead center, and this is ODC, means outer dead center. So crank will rotate from IDC to ODC, means 0 to 180 degree. In this image you can see that. So it will rotate like this, 0 to 180. So at that time, that create the partial vacuum from left side, means here, of the piston in the cylinder.
First open YouTube and write down Engineering Guru 2020. Search. This is Engineering Guru YouTube channel. Open this and subscribe this for more updates. Various playlists available here. You can see This is for various subjects. This is for velocity diagram, uniform velocity, for cam profile, synthetic linkages, and more video, more playlists are here.
The pressure in the sham is atmospheric, while pressure on left side of the piston inside the cylinder is below atmospheric. This pressure difference causes suction valve to open and the water is forced to enter through the suction pipe to the left side of the piston. Now understand? So whenever it go 0 to 180 means IDC to ODC. So in cylinder left side pressure difference is generated. The pressure inside the cylinder is below atmospheric and that some pressure is atmospheric. So due to this difference the suction valve will be open and water is forced means hinge by water is forced like this to enter through a suction pipe to the left side of the piston. So when the crank reaches IDC, the piston is on extreme right position and the suction is completed. The cylinder is full of liquid. So whenever that crank reach at ODC means at this point at 180, the cylinder means this cylinder is full of liquid. So during the delivery stroke, the crank rotate from ODC to IDC. That means 180 to 360 degree and clockwise direction. The piston move from extreme right position toward the extreme left position. Now understand. So during the delivery stroke, the crank rotate from 180 to 360 means this 180 to 360 degree. In this image, we can see that this is 180 to 360 means cover this area. So at that time, the pistons move extreme right position toward the extreme left position. This movement of piston increase the pressure. This is the most important. At this moment, the piston increase the pressure of the water in the cylinder, which cause the suction valve to close and deliver valve to open. So due to the increased pressure, the suction valve means this valve will be closed and this delivery valve will be open. You can see here this is pressure release. So this delivery valve open and this valve will be closed. Thus, the water is forced into the delivery pipe and raise the required height and the end to delivery stroke. The crank comes to IDC and the piston to the extreme left position. So that water will enter, or we can say the water is forced into the delivery pipe means here it raises to required height. At the end of delivery stroke, the crank comes at this point IDC and piston will be in extreme left position means that move like this. The variation of discharge of water Q through the delivery pipe with the crank angle for single acting reciprocating pump. Discharge obtained single acting pump is intermediate as discharge obtained during delivery stroke. As the piston has simple harmonic motion, the discharge curve is the sine like this. This is called sine. Now understand. So this is from IDC to ODC. So whenever the crank move like this, the pressure is generated. So water enter, and whenever the crank from ODC to IDC, pressure is enter, and whenever it ODC to IDC, this valve open and water will pass through delivery valve to delivery pipe. So this is the basic concept, or we can say working of single acting reciprocating pump. So in university, the question may be asked: draw the neat sketch of single acting reciprocating pump with nomenclature. So this is the end of this video lecture. Stay on this channel. More video will become this topic, pistons. If you find my video very helpful, subscribe our YouTube channel. You can join us on FB page, Telegram channel, WhatsApp channel, Engineering Guru 2020. So if you find my video very helpful, you can like, comment, share and subscribe. Stay on this channel. The more video of this pump will be published very soon.